Hello, my name is Jun Kamei. I am the CEO and founder of Amphico. Today, we would like to present our grant-funded project by the April Impact Institute, the waterless textile coloration through optical color mixing. Amphico is a London and Tokyo-based material science company with expertise in textile, and notably performance textile. We have a track record of bringing material innovation from lab to mass manufacturing, notably for our PFAS-free, waterproof, and breathable textile that can be applied for outdoor wear and then outdoor gears. This is an overview of the problem that we want to solve through our solution. Currently, the textile coloration process is estimated to be responsible for more than 1% of global emission and 20% of global water pollution. Concretely, there is a large emission coming from textile dyeing due to its very energy-intensive process, and a huge amount of toxic dye are discharged through effluent, and it also consumes a vast amount of fresh water. It is estimated that the footprint of textile coloration represents 30% of total carbon footprint of an apparel product, which is very high. Through this project, we're going to reduce the process demand for energy and water through our waterless coloration technology that can be applied on multiple woven textiles. So conventional dyeing happens with yarn extruded being then woven into an uncutted fabric, which is then put into a dye bath filled with water and with colorant added. Temperature is heated up so that the dye material is then taken into the fabric. The dye which were not taken into the fabric are then washed off. This results in toxic effluent, which would contain those toxic dyes. The colored fabric is then dried and heat set on a stanter. Our waterless coloration uses dope dyeing. We add the colorant in the beginning during yarn extrusion, and we create a limited number of primary colors. The reason we focus on a limited amount of primary colors is to limit the number of colors that has to be produced and reduce the amount of stock that needs to be created for each of the colors. Basically, in dope dyeing, the minimum amount that needs to be created is approximately 1 ton per color. By minimizing the amount of primary colors that we have to create, we minimize that stock risk. Then what we do is those primary colors are then mixed together during weaving. And just like in printing, where you can create a multitude of colors starting from a limited number of ink color, we can create more than 10,000 colors possible by mixing the colors, primary colors, optically. Then the colored textile are then washed, dried, and heat set on a stanter. When you look at the footprint and the process, the gray zone is similar. It constitutes of the yarn extrusion and the weaving process. Then the drying and heat setting on the stanter is also similar, both in the conventional and our waterless coloration method used for textile. But then what is different is that for our waterless coloration method, this part in orange is not included. And this is actually the section which consumes the most energy and also consumes the most water. So therefore, in our waterless coloration method, by removing that orange section, we are able to reduce energy consumption by 50%, have zero discharge of toxic dye chemical, and then reduce the water usage by more than 90%. This is an example of optical color mixing being used. So the jacket looks gray, but there's no grain being used. When you have yarn being small enough, our eye cannot discern the difference in the yarn colors. So for example, in this case, the black and the white end up being mixed together and result in the perception of a mixed color, which is gray in this case. So the objective of this project is to evidence the scalability, the wide color availability, and reduction of CO2 equivalent and cost of our waterless coloration method at industrial scale. We're going to deliver a prototype woven fabric of over 8,000 colors, prove that this is applicable to different facilities with the difference in color being lower than delta E1, reduce the color disparity between production and the actual woven samples, create a first scale production for listed brands and facilities, and have all of the primary data which support the reduction in CO2, water consumption, and the cost. This is the implementation plan. So first of all, we're going to create the primarily colored dope dye yarn. Then these primary colored dope dye yarn will be mixed during the weaving process in order to create over 8,000 colors in woven form. We'll then develop a color prediction system so that we can very efficiently design what fabric needs to be created in order to achieve a specific color, and implement tests with brand with a specific set of color palette. And we'll also mass manufacture during this project as a trial and implementation to prove readiness for the industry. In terms of effectiveness, we see the maximum potential saving of this approach to be 62 megaton of CO2 equivalent. And these are the CO2 equivalent reduction per unit textile. We're going to work with 3 sites, notably all woven weaving factory mills based in Asia. And during the duration of this project, estimate to reduce over 3,000 tons of CO2 equivalent. And taking into account the cost of this project, have a cost of ton of CO2 equivalent reduction being equal to $53.7. By 2030, we're going to increase the penetration of our method, which will result in over 38,000 tons of CO2 equivalent being saved and reduce the cost to 1/10. From a scalability perspective, the funding from Upper Impact Institute is going to fund and support scaling. And this is by de-risking and helping us secure evidence of upside of our waterless coloration method to increase implementation by facilities and brands. So it will allow us to provide evidence of color quality, color availability over 8,000, and target color achieved at a delta E of lower than 1 at industrial scale and different yarn size. It would help us provide evidence of the cost reduction effect that is estimated to be possible with our waterless coloration method. And finally, it will help us provide evidence of increased sustainability, such as 50% reduction in CO2 emission, 90% reduction in water consumption, and 0 discharge of toxic colorant. So these are the deliverables. So we're going to monitor the energy consumption for each of the processes. We're going to monitor the water consumption for each of the processes. The cost of proposed process and saving made will be calculated using primary data. And we'll check the color disparity across different facilities and between prediction and sample to prove that this is scalable across different facilities and usage. So thank you for your attention. We are Amphico, and we're excited to share our journey on this project, the Waterless Coloration Project. Thank you very much.